Hey everyone. In this video, we're going to be talking about aromatic compounds. Now, as we previously learned, aromatic compounds have a six-membered ring with alternating single and double bonds. Now, these double bonds can be represented by either of two structures. You can have the double bonds drawn here, here, and here, or you could rotate them and orient them here, here, and here. Now, for reasons we don't go into in this class, these are the same structure. It doesn't matter where you draw the double bonds. They actually can rotate around the ring through something called resonance. And so because of that resonance, these are the same structure. Now, to simplify that, a lot of times it's abbreviated by just drawing a circle in the middle of the ring, and that circle implies the three double bonds. And this is just showing that it doesn't matter which way you draw them, there's just the three double bonds. And if you want to draw it as a skeleton structure, you could just draw it as the hexagon with the circle in the middle. These four different representations all mean the same thing. So aromatic compounds are really common. You don't need to know any of these structures. These are just some common examples where you see aromatic compounds in everyday compounds. So ibuprofen has an aromatic ring. Acetaminophen, which is the main ingredient in Tylenol, has an aromatic ring. Aspirin has an aromatic ring. Vanillin, which is the molecule responsible for the smell and taste of vanilla, has an aromatic ring. So really common in a wide variety of molecules that you guys use every day. So let's get into some specifics here. Benzene is the simplest aromatic compound. When you just have an aromatic ring all by itself, it's known as benzene. That is its name. Now, when you have a benzene ring as a substituent within a larger molecule, it's known as a phenyl group. So this isn't benzene because it's not by itself. This is a phenyl group attached to a larger parent molecule. Now, let's talk about how to name benzene derivatives. So any aromatic compound that has the benzene ring as the parent, it's called a benzene derivative because it's derived from benzene. When there's two or more substituents, the ring is numbered to give the lowest numbers to the substituents. So here's some examples. If you have a chlorine attached to benzene, this would be chlorobenzene. You don't need a number because there's only one thing attached to the ring. If you have two chlorines on the ring, it would be dichlorobenzene. But those chlorines could be attached right next to each other. They could be slightly apart, or they could be on opposite sides of the ring. And so now we have to specify where they occur. And so this is carbon number 1. This is carbon number 2. So this is 1,2 dichlorobenzene. Or carbon numbers 1, 2, and 3. So this is 1,3 dichlorobenzene. Or carbons 1, 2, 3, 4. So this would be 1,4 dichlorobenzene. So we use numbers to specify where the substituents are attached if there's more than one substituent. Now, if this wasn't complicated enough, there are several common benzene derivatives that have common names. And these common names have been used historically. They've been known by these names for hundreds of years. And so these names were adopted by IUPAC. And so you have to memorize these common names. If you have a methyl group attached to benzene, it's known as toluene. If you have an NH2 attached to benzene, it's known as aniline. And if you have an OH or an alcohol attached to benzene, it's known as phenol. The OL is different than the YL. YL is phenyl. OL is phenol. So phenol is OH on a benzene. Now, if you're naming an aromatic compound that has toluene, phenol, or aniline as the parent molecule, we use that as the parent name. So for this one here, that is aniline. So by default, we give carbon number 1 the position where the aniline is attached. And so this would be carbon 2, and this would be carbon 3. And so the bromine would be attached to carbon 3. In this molecule here, this is the parent. The OH on a benzene is known as phenol. And so we give that carbon number 1 by default. And then to give everything the lowest numbers possible, that's carbon 2, that's carbon 3, and this is carbon 4. And so this would be 4-bromo, 2-chloro in alphabetical order. And last but not least, this one here is the parent, and that is toluene. And so by default, that gets number 1, 2, 3, 4, 5, and 6. And so in alphabetical order, B comes first for bromo. And so at carbons 2 and 6, we have dibromo, di because there's 2 bromines. And then at carbon 4, we have a chloro. So 2,6-dibromo, 4-chloro, toluene. Let's do some practice. Name each of the following molecules. All right, so looking at this, we need to figure out what the parent molecule is. And it looks to me like this is the parent, which would be phenol. And so to number it, that's number 1. This would be 2. This would be 3. This would be 3-chlorophenol. And there shouldn't be a space between those. So let me scoot that over. 3-chlorophenol. All right, the next one. What's the parent? Looks to me like that is our parent chain. And we know that this is named toluene. And so by default, that gets carbon number 1. So that's 2, so that's 3, and over here is 4. And so at carbon 4, we have a fluoro group. So 4-fluorotoluene, and there's no space there, so let me scoot that in. There we go. So 4-fluorotoluene. All right, next one. Pretty sure this is the parent, and that is known as aniline. So that gets number 1. So that's number 2, and that's number 3. And so at carbon 3, we have an ethyl group. So 3-ethyl aniline. And the last one is actually the simplest because the parent is just benzene. And there's only one substituent, and it's got 3 carbons. So that's a propyl group. So this is just propyl benzene. Nice and easy. All right. So to recap this video, an aromatic compound is anything with a six-membered ring with alternating single and double bonds. The ring by itself is known as benzene. If it's part of a bigger parent molecule, it's known as a phenyl group. If we have multiple substituents, we need numbers to specify where they occur. A single substituent does not need a number. And there are three common benzene derivatives that you need to know the names of. Methylbenzene is known as toluene. An NH2 attached to benzene is known as aniline. And an OH attached to benzene is known as phenol. So that's the end of this video and the end of chapter 11. Thanks for watching, and I will see you in lab this week.